Our first two questions deal with Pythagoras' theorem. Okay, we talked about Pythagoras' theorem and how the sum of the squares of the two legs. Okay, so square A, square B, and when I add that together, that gives me the square of C. So we're talking about A squared plus B squared equals C squared. Okay. So for any three sides of a triangle to be considered a right triangle, the sum of the first of the two smaller numbers must equal the square of the largest number. Okay. Now, 3, 4, and 5, and 5, 12, and 13 are Pythagorean triples. They're well known to be and create right triangles, but it's not giving us 3, 4, and 5. It's giving us the square root of 3, 4, and 5. So when we square a square root, that's the same as saying the square root of 3 times the square root of 3. Okay, because it's anytime you square a number, you're multiplying it times itself. Well, the square root of 3 times the square root of 3 is the square root of 9, which equals 3. Okay, so anytime you square something inside, anytime you square a square root, whatever's on the inside is what your answer is going to be. So the square root of 4 squared is going to be 4, and the square root of 5 squared is going to be 5. This does not equal, 3 plus 4 does not equal 5. So A, as is B, because 5 plus 12 does not equal 13, okay? Now, if I have 9 squared plus 16 squared, does that equal 25 squared? Well, 9 squared is 81. 16 squared is 256. And 25 squared is 625. So that does not equal 81 plus 256 does not equal 625. So obviously our last answer is correct, but just to show you, 7 squared plus 24 squared, and we already did 25 squared, which was 625. Well, 7 squared is 49, and 24 squared is 576. And when you add 576 plus 49, you do get 625. Okay, so that's why 7, 24, and 25 are, or I should say is a Pythagorean triple and forms a right triangle. Okay. 2A just asks you to plot the points. So -7. So 1, 2, 3, 4, 5, 6. -7, positive 1, 2, 3, 4, 5, 6, 7, 8. Brings me here. And then point B is -2, -1, 2, 3. Okay. So we plot the points. And then 2B says to use the Pythagorean theorem to find the distance. And we're asked to leave our answer in radical form. Okay, and I'll show you what that looks like in a second. All right, so we're going to, again, this is C. And this should be a review for you based on prepping for MCAS and finding distance. Okay, so I've got 1, 2, 3, 4. So this is 5. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to recount that just to be sure. And actually, oh, right, yeah. 8, positive 8 to negative 3 is 11. Okay, good. Okay, so this is 11 and 5. And so this is supposed to be the letter C. Okay, so let's see. So we've got 11 squared plus 5 squared equals C squared. So 11 squared is 121 plus 25, because 5 squared is 25. 121 plus 1 plus 25 gives me 146. Okay, and so that equals C squared. Now, to get C, remember the last step is to take the square root, 146. Now, when you take the square root of 146, that is not a perfect square. And because it tells you to leave it in radical form, I would just let you leave it as a square root of 146. But technically, we could reduce that. And we reduce square roots just like we would create a factor tree. And we want to pull out as many perfect squares as possible. And as it turns out, this really can't be broken down any further. And the only reason I know that is process of elimination. I tried dividing 146 by several perfect squares, 4, 16, 24, and none of them give me a whole number. Did I say 24? Yeah, 24 is not a perfect square, sorry. 4, 9, 16, 25, 36. And none of them give me a whole number. So, but 146 is even, so I did divide it by 2. And what I get is the square root of 2 times the square root of 73. Now, 73 is a prime number, as is the number 2. So this truly is, this cannot be factored any further and would be your final answer. Okay, question number 3. A ladder is placed on the wall that the top is 8 feet above the ground. If the ladder is 10 feet long, how far away is the wall from the base of the ladder? Okay, this is also Pythagorean theorem. This is A, number B, and C. And C is always our hypotenuse and is across from our right angle. So we're gonna do A squared plus B squared equals C squared. So 8 squared plus B squared equals 10 squared. Okay, so this is 64 plus B squared equals 100. Now, I want to find out what B is, so what we have to do is actually subtract 64 from both sides so I can find out and isolate B. And your last step is always to take the square root, and my final answer would be 6. Okay, number 4. During the storm, a tree breaks 4 feet above the ground and falls to form a right triangle. Okay, so if a tree breaks at 4 feet above the ground, so that's 4. If the top of the tree rests 11 feet from the base, so here's the top of the tree, okay, it fell over, and it rests 11 feet from the base of the tree, which is here, so that means from here to here is 11, okay. How tall was the entire tree before the storm? Well, again, you're going to use A squared plus B squared equals C squared. You're going to use Pythagorean theorem, this being C. I've already done Pythagorean theorem enough for you. So same exact steps. 4 squared plus 11 squared equals C squared. Make sure your last step is to take the square root of whatever the sum of 16 and 121 is. And then whatever that value is if it wants the height of the entire tree, you're going to do whatever C equals, and you're going to add 4 to it, because this is the 4 feet where it broke, would be the total height of the tree. I know that's really difficult to read because my point's a little too thick, but so yeah, so the top of the tree, the total height of the tree would simply be the length of C plus 4. Okay. This number 5, quite honestly, I hate this question because it's counterintuitive to me. First of all, we have to draw a picture so you understand what we're talking about here. So we have a triangle ABC, and it says BC is 15 and is the longest side of the triangle. Okay, so if you notice, again, we're looking at Pythagorean theorem again. Okay, and if BC is the longest side, that will act as our hypotenuse if our triangle happens to be a right triangle. Okay. So now it's asking if AB, which I'm going to label X, if AB squared plus AC squared, which I'm going to label Y, if the square of the two legs are greater than, and as you notice, 15 squared is 225. The question is the triangle acute, right, or obtuse? Okay, now, the reason I say counterintuitive is because the rule states that if A squared plus B squared, or based on my diagram, X squared plus Y squared, is greater than the longest side squared, then our triangle is actually an acute triangle. And the reason being is that it goes back to the fact that the longest side is opposite the biggest angle, or the shortest side is opposite the smallest angle. Okay, so if my two legs, which I labeled X and Y here, if I square them, and if that's greater than that 15 squared, that means this angle C is opposite X, angle B is opposite side Y. Okay, so if the lengths are greater, that means the angles are smaller. And when we categorize a triangle, we categorize it based on the angle measures, not the side lengths. Okay, that's why we call any right triangle a triangle that has a 90-degree angle. Okay, and so of course the opposite is true. If the side lengths are shorter, okay, less than, the side lengths are shorter, that means the angles are bigger. So that means this is an obtuse angle, okay? Quite honestly, I'm not gonna include this question on your test, okay? I'll have it on there, but I'm not gonna penalize you on it. But that is the reasoning behind this question.